Hi. If some engineer has to create a 3D structure in SCIA Engineer, then he needs some background information, some drawings, some blueprints. Mostly you get it in form of CAD files like DWG or the XF files, sometimes PDF files. But last years there is a common way how to exchange the data between CAD software and calculation software, and this is so-called IFC file. IFC is an abbreviation of Industrial Foundation Classes. It is a text file where the complete structure, the geometry of the structure, is saved. And the topic of this video is to import this IFC file, explain what types of IFC files you can get, and how to create from this so-called structural model or architectural model one analysis model which you can calculate in SCIA Engineer. And for this task, we have in SCIA Engineer so-called BIM tools. It's one function with one menu which can change the structure and help you to create the analysis model. So this is the topic of this video. My name is Ivan Beleš and I'm support engineer for SCIA and Idea Statica. First, a short explanation of background information, because you will need it. I get a lot of questions about these backgrounds, and I see that people don't know it. So, there are two common versions of IFC. So, IFC, as I told, is Industrial Foundation Classes. There is also a national code for it. So it's really only one way how to exchange 3D model between the software. There are also another interfaces, but this IFC works really very good between all the programs. So there is IFC 2x3. SCIA Engineer can import and export this file. And then there is SCIA Engineer, there is IFC 4, which can be imported into SCIA Engineer. IFC 4, or SCIA Engineer supports in IFC 4 the same objects like in IFC 2x3 and a little bit more description of these 3D objects. Before you import this file, please check it in some viewer. There are a lot of viewers. They are for free. You don't need to buy it. Nemetschek has one. There is one from Autodesk. There is from Tekla. I am using the IFC viewer, the IFC viewer which is called Solibri, because if there are some issues with this IFC file, then I have seen that this is a program which gets me most information about all these issues and errors. And if you want to do more with it, then this is a small tip. There is one IFC analyzer. It's from National Institute of Standard and Technology. I have the link in the description of this video. You see it also on the screen. It's a program which takes the IFC file and create you one Excel. So you see how much columns you have there, which materials are there, and walls and so on. So you see a little bit more than in this on the screen. So we have the versions. Then the IFC, the extension IFC, can contain more types of descriptions. And this is in IFC 2x3 called views. There is so-called coordination view, and there is structural analysis view. There are more of them, but these two are very common, and we will use it. You will get it also. In the coordination view, you have the description of the architectural model. Each member is separately described there on different ways, but it's described there. And there is a structural analysis view. The idea behind it was to have some format to exchange the analytical model between the static programs, between the competitors. It's almost not working because this interface, the development was stopped some years ago, but the programs continue growing. For example, in SCIAEngineer, we have subregions, we have variable thickness, and a lot of objects, they are not included in the description of this structural analysis view. So SCIAEngineer is not supporting it. There is one way how to convert this analysis view into XML and then import XML. So there is a possibility, but not the direct import. So for you to know if you want to import it into SCIAEngineer, you need this coordination view. You see it in the file. If you open this IFC file, this is a text file, you can open it with Notepad, for example, on your computer. And in the header of the file, you see if it is coordination view or structural analysis view. You can open it also with the Solibri, and if it's different format, you get an information. That is it. So for us, we need coordination view 2, x3 or 4. Then there is the header of the file, and there is also the description of all these objects, columns, walls, plates, and all openings, whatever you want. And there are two common ways how to describe these 3D objects. The first one, which we want, is swept solid. In swept solid, you have chronological description. You have, for example, a column starts with description of nodes of the cross section. So you get one row with one node, next node, and so on. Then you get a polyline which connects these nodes. Then you get a description that we have a cross section with this polyline. And then there's a start point, end point, coordinate system, rotation of the coordinate system, and description of the column is that we have the column from this point on this line from to the end point on another line with the coordinate system and with a cross section. So you get a full description which can be directly used in SCIAEngineer to create a column. We have axes. By the way, in the CAD softwares, you can draw the columns or walls not only in the center. You can say, I draw the column in the left bottom corner, for example. This is my reference point and the cross section is going from this point. Or you can say, I draw the walls on the outside boundary of my building. But during the export to IFC, the middle axis will be exported. So this definition, how the column or wall also was created, is forgotten. So everything will be placed on the middle axis. So this swept solid is a good description for us. We can simply read it. We have a column, we have a plate and everything what we need. It's not perfect analysis model, but we get members which we can use for the calculation. And there is another description. It's the abbreviation is BREP, boundary representation. This is like you would buy, instead of your shoes, you would buy only the box of your shoe. So in the boundary representation, you get only description of the the faces of your 3D object. And then we get this 3D something, and in SCIAEngineer you have then to change it in 1D or 2D objects. So very often the decision if it is exported from the CAD to IFC, if you use the swept solid or boundary representation, you can decide it in the software, in the way how you create the object, or in some programs you have, for example, Archicad is using this IFC translator where you can define it. So you have to simply to use the right definition for the export, and then you get correct object description. So you see here one example of a column. This is swept solid. You see these red lines. This is the description of the nodes of my cross section. Then we have on the row 45 we have description of the polyline. On the row 46 we have the cross section. Then 47 to 56 is the description of the start point, end point, rotation of coordinate system. And on the line 61 we have this IFC column, which consists from the line 6, the name is B1, then we have 51. 51 is the local placement. 60, what is 60 is the definition of the line, and this is the description of my column. So we get the axis and cross section. Sometimes it's not correct cross section, sometimes it's imported as a general cross section, so you have to convert it sometimes in SCIAEngineer, but mostly it works. And this is on the left side, you see the boundary representation. This is like a shoebox. So you get only these faces and there is nothing. So the axis is there. I draw it because this is a drawing from SCIAEngineer, but you get only these colored axis, colored faces, and this is then imported. Sometimes they are also open, so there are gaps between the lines. Then you get open shells, and you cannot convert it into 3D because SCIAEngineer cannot imagine what is in these gaps. So this is sometimes difficult. If you get such IFC file from your partner, if you can communicate with him, call him, ask him if he can export it with this swept solid description. Then the objects has also material. This is sometimes difficult because the architect don't write C2025, they write concrete. Mostly. Sometimes even this not. So you have to transfer these names of the materials from the CAD program to something which is in the national code, steel or concrete or something else. And for this we use text file which you can create. So I will go through it, and the question is if we should do it later. I go directly into it. So how to import IFC file? You go to File, Open From, IFC file. It's very simple. And I have saved here some projects. This is this demo house. This is from one presentation, old one, some years ago. Here is the material table, where I could select the text file with the conversion from the materials from IFC file to materials in SCIAEngineer. I will not do it. I will simply import the file, and then I get cannot import following materials. Beton, Stahlbeton, Decke is German, sorry. Sometimes you get very strange names. Don't think that this is the name of the material. The full line is the name of the material. So you have to convert this full line into something different, like example C2530 or so. So we have to do it but I don't want to write all these materials. I will save this log file, import.log, and I will forget it. So I will not use this imported file. We will open this import file, and you see on the screen this log file, this import.log. We can delete all this text, and we leave only the names of the materials in the IFC file in the text file. So, and now we can check how should be the syntax. So the extension is .con, and we need the text materials in square brackets. So we use materials. And then what do we have? Semicolon. Okay. Then use some semicolon. And then we have the name in the IFC file is equal to a name in SCIAEngineer. So, sorry. So I will write this name is equal C2025. If you have a blank in SCIAEngineer in the name of the material, you have to write it correctly. So everything have to be written. So I will copy it here and here. So should we have some blank between them? No. Okay, that's everything. Usually I leave at least one empty line in the text files. This is from my DOS times in the past, so forget it. So I use it. It's not a bad behavior to have it every time. So, and now we can, how can we save it in this program? Save as, and we write material.con. You can use also another name, for example, YouTube video.con. It's con, the correct name, .con. Okay, and save. So we don't need it anymore, and we can import our IFC file again. This was this one. And now I can select the file, open it, and that's all. So I will import stories. These are objects. They are included in the file or could be included. I know there is no reinforcement, no tandems for pre-stressed structures. Others, these are 3D objects. I will import it. And you can import everything which is possible as members. That means if there is this swept solid description of some wall, plate or column, then it will be imported as a 1D or 2D object in SCIAEngineer. Or you can say, I want to have everything as a 3D object. Maybe you need it only as a drawing, so then don't need it to calculate. I don't know what is analysis shape only. And a run member recognizer I would not do automatically. This is better if you run this member recognizer separately for selected objects. This is not the part of this video. Maybe I will create some another video of it. So we leave it. This is Eurocode. You can check it if it is really Eurocode, and okay. And then we get the imported file without these issues about the materials. So we have only one unsupported side. This is IFC side. It's not an issue for me. And then we get this 3D structure. So I will not continue on this 3D structure. We will go to another model, but later we go back. We can come back to it. If you import this IFC, sometimes I get a question, can I select some template for the import where I have, for example, layers or load cases already saved? Not, this is not possible. The IFC import is using predefined template. You cannot change it. And but what you can do is later, after the import, you can insert your model from IFC file to your template, or on the opposite way, you can insert your template into the model, whatever you want, both will function. This template has a little bit old format, and therefore you have to do some steps to get your model or your file on a correct stage. So you have to go to project settings, functionality. So you see the materials. You can deactivate something if you don't need it. Functionality, and there is code-dependent deflections. Usually, code-dependent deflections, if you create a new file, are automatically activated. So if you create a new project, you will never see this option. And also, if you activate it one time, then it's done. It disappears, it's activated in the project, you will never need to activate it again. So it's only one time to activate because it's a little bit older template. And what you also have to do, usually you have subsoil in your model. So the subsoil is also standard activated in new models. If you have 3D model, then one time activated, and that's all. Now we have the project on a good level. After the import, you have to do some steps, and we can look at it in our model. You get a lot of trash, usually in the IFC file. You see the flowers, you see the furniture in the rooms, you see the Mercedes in the garage. I don't know why they draw every time only Mercedes in the garage, but there is every time a Mercedes there. So you have to delete them or keep them on some layer which you don't need. But usually I delete everything. To make a difference between objects you need and objects you don't need, there is one property of the objects which is commonly used, and this is load bearing. This is in all CAD softwares I know it's included. So it's also in SCIA Engineer. You can simply check, and you see structural model, BIM properties, attributes, load bearing. You see it's activated. So if you want, you can go right mouse button, expand selection. Now we have selected all objects that were marked as load bearing in the CAD software. Control E, we have activated only these objects. Now you can go to the visibility and invert the visibility, so you see the objects, they are not as load bearing. So, but we will need them, so this was not correctly defined. But on this way, you can make a difference between objects you need or don't need, usually. Or they are on some separate layers, or they have some different materials. But this load bearing is a very good way how to do it very quickly. Then you have some 3D bodies, some 3D members. You can convert them. So there are, I don't know, where is it? BIM toolbox. Yes, this is general solid 1D to 2D. Part of a general solid if it is something complicated, for example, bridges or so. Or you can convert back from 1D or 2D to 3D solid, sometimes necessary. So we will not do it. I will simply delete all these objects which we don't need. So these are correct 3D solid, right mouse button, expand selection, and simply delete them. And I will also don't need these columns. And Control Q, I see the full structure back in the model. Also, these two walls are not necessary for me at the moment. This is a demonstration. I don't need to sell this project. Okay, sometimes these shapes, these 3D objects are created from open shapes. They will not be able to convert to 2D or 1D then you have to simply draw around them. If you need to this 3D geometry, then there is object snap category, this solid vertices. So then you can use the corners of these 3D objects to draw your geometry. And okay, and then you have to assign the correct material. You have to check it. What you can do is to use the input table. In the input table, for example, for 2D members, you see here the material C2025. You can use the filter row. You can sort from top to bottom, bottom to top, so we have everything correct. If not, you can change it. You see it here, and you can select the members. They have, for example, not the correct material. Then you get the selection here, and you can change the material if you want. And the same you can do also with the cross sections. You see it in the libraries. In libraries we have cross sections, and in the cross sections you see the material. Please check the material. Sometimes I see that the people mix material from Eurocode 2 for buildings and Eurocode 2 for bridges. We can go to material. You see C2025, and there should be also C2025 from Eurocode 1992-2. And these are two different materials. If you have ribs which are connected to plates, then the rib need to have the same material like the plate. If not, then it's not calculated. It doesn't matter that the values are the same. It's from different code, it's a different material, and SCIA Engineer will not calculate you the reinforcement for the rib. So you need the same material for the rib and for the plate. And I see it very often after the import of IFC, the people, if you draw it, then you know which material are you using for the plate, and you use the same also for the rib. But if you import it, then sometimes the people forget it. Okay, and then check and change cross sections. We have the cross sections. These are rectangles. Sometimes you get here, if the geometry is not really correct, you get a general cross section. So then it's better you will change it. You can here element change type. So you can change completely the cross section. If you go only to edit, then you are in the rectangular cross sections. You can change the dimensions, but you cannot change it from general cross section to rectangular cross section. So if you want to do it, you have to use this function and change the type from general to rectangular cross section. Okay, and let's say now we have some rough model with our objects, and continue. Why should we do the next step? And this is the alignment. The alignment, you see this picture. I've stolen this picture from the University of Vienna. They had it on the homepage. So I have created in SCIA Engineer some small model, because it's a very good demonstration. Why do you need this alignment? You see the walls has a different thickness, and of course, if you draw it in your CAD software, you use the outer boundary of your building to draw it. So the axis of the bottom wall, which is thicker, and the axis of the top wall are not the same. So, and you cannot keep it on this way in your 3D model, because you get very high shear forces in your slab. So you need both walls, one over the another. They should be in one plane. This is one thing which this alignment is doing. And then, and also with these slabs. The next step which is done is to move the nodes. You see the wall stops on the bottom on your slab, and also the column, and they have to be moved, and also the walls are not connected in the corners. And you have also these ribs, they are in 3D, so you have to move it in the plane of your plate and convert it from standard member to a rib. So all these things can be done in the alignment. And then if everything works, you get a nice 3D model which you can calculate. What is the background in it? In the CAD software, you have a completely different description of a 3D model. Each member has a separate start and end point. Also, if you have two 1D members, for example, from one point to this point, from second point to third point, in the CAD software, you get point 1, 2, point 3, and 4. And in draw it. In the CAD, you have point 1, point 2. And if you have another member, then you get point 3 and point 4. This point 2 has separate X, Y, and Z coordinates. This one also X, Y, and Z. So these members are completely separated, described, and also walls. But in the analysis software, we have one table with nodes. We have node 1, 2, 3. And there is a description of 1D member, and there is 1D member, for example, B1, and B1 goes from N1 to N2. And then we have B2, and it's going from N2 to N3. So we have only one node here. So this is the big difference between all these programs. We need to create a correct analysis model. So we will do it on this model. I have created in SCIA Engineer, so I can simply open it and go to, is it this simple model? I hope. Okay. This is my simple model. The same as on the picture, optically. And we can now start with the alignment, okay, after half an hour. But sorry, if you don't need it, you can skip simply in YouTube. This is not an issue. So where we have our function, BIM toolbox, alignment. Because I will need it very often in this video, I simply move it in the process bar. So start alignment. Do you want to process with all entities? Don't do it, because then this alignment is going through your full model and mainly it will not work. So deactivate the dot grid. What you need to do is select your members. The best way how I am doing it is also to see them only on screen, go to top view, and now I can select the members. I will do it also on the bigger model. So now we could maybe run it through the full this small model would be not an issue. So align members. No, I don't get this question because I have selected the members. If you go back, let's say we have visible only two walls, and I will start align all members. If I say, do you want to process with all entities? And I say yes, then all entities will be included into the alignment. If they are deactivated or activated, it doesn't matter. So therefore, you need really the selection. So select and run the alignment. Sorry, I explained the basics, but this is a little bit complicated thing and I get a lot of questions about it. So we have show alignment. I go through everything. Show alignment info. This is this box. First weeks, years ago, after I started with this menu, I have simply deactivated. I didn't know what is it doing. So it was one unnecessary screen for me and I have deactivated. So you will need it, so don't deactivate it. Then we have live preview. Live preview, you get some action preview. Sometimes you have to go to another page and then back. And you see align action preview, all 1D members, all 2D members. You can activate it, or for example here. And you see a blue line, what will SCIAEngineer do? And you see this smaller wall will be moved to the bigger wall. And in the past, I think in the biggest surface of the wall is important, not the volume of the wall. I have another 2 walls where I can show it. So leave it open. One of these walls will be defined as a reference wall. So we have these so-called master planes. So this is the first task of this alignment, is to find master planes. These master planes can be of different type. So the first one is also the most important. If you have more planes, then this one, which is on the top, is more important as a priority before of the local coordinate system of the planes. So user coordinate system, what you can do? You can move your coordinate system to some another point, and I move it here. I will not do it, but you can do it. You can move it with rotate and all these functions, and then you can save your coordinate system. There is also a manager, and all this coordinate system, this actual user coordinate system, and also all saved user coordinate systems are master planes. So SCIAEngineer will use it for moving of nodes into these master planes. If you have 2 master planes, then one of these, and they are within this distance, 40 centimeters, then after the alignment, only one plane will remain in the model. And this is the plane which has higher priority. So if you have some user coordinate system and 10 centimeters behind them is wall, then the wall will be moved into the user coordinate system. And also if you have 1D members, they will be moved into the wall. And if you have, so this is only the dimension, you can extend it. So we can see these planes. They are on the bottom, highlight master planes, and there is also highlight not preview, show master planes. Okay. So we see this master plane, and we can also make it a little bit bigger. So you see also this one master plane on the bottom, and you see the wall will be moved on the bottom because this is the plane of user coordinate system. If I will deactivate it and go back, show the actions, you see this small horizontal plate on the bottom is not there because this was the plane of user coordinate system. It was global coordinate system, but also the user coordinate system. So we see now the planes, and we can extend them. Sometimes they are too small. There is this offset of master planes. You can extend them. 30, 50. It's done automatically. 30. I think we have to deactivate it. And master planes. And activate it. I don't know. This is extend master plane. Okay. Now they are automatically extended. They are a little bit bigger. So the first task is to identify master planes and move them together if they are within this distance. And if they have an angle, one to each another smaller than 1 degree. So you can change it. And then you have the correct angle of the master plane. So this is okay for us. We don't need to change something. We can leave it. Then, during this movement, the nodes will be taken and moved. The maximal distance where SCIA Engineer looks for another nodes, they should be moved to this master plane, is 0.51 meter. And the maximal distance is also the same. I will explain it on another model. So, this is a good definition. I will keep it. I say save and new, and then run alignment. I don't know if it was done. Okay. What do you see? The wall was moved from this position to this one, but the boundary is still there because I have used this definition in the alignment. It's on the bottom. Keep original shape of the model. That means if the plane will be moved, this movement will be written in the eccentricity of your plate or wall or column. Then you get more precise model, but you get also one issue, and you have to decide if you want to use it or not. What is my issue? We can do it here. Right mouse button. So, we have one wall and another wall. And there is also plate between them, for example. And this wall will be moved. So this will be my new center line. This is the old center line will be moved. But the geometry of the wall remains on the same place. That means if I have another plate and then I get load, then this, and for example, I have hinges there. Then I get the load here over the hinges, over the center and back down. And I have an additional bending moment in the wall and probably also in the plate. I know it because sometimes the people ask me, Mr. Beleš, I have a plate, everything with hinges, but I have bending moment there on the boundary. Yes, this is because of this alignment of IFC. So, if you want to keep it, then you can use it on this way, keep original shape. If not, you can deactivate this button, or you can do it also later. We can go out of this menu, you can do it later, and then you have the thickness, the eccentricity, and you can change eccentricity to 0, and then it's also forgotten. So, Ctrl Q, we see back the full model. So, after some minutes of explanation, we have only 2 walls. This walls has the same thickness, so we can simply select all these walls, go again to the alignment and say live preview what will be done, and you see all these walls will be moved to one corner. That's okay for me, and run the alignment. I will not care about very precise and detailed way how we do it in this model. So, but this is the way how I am processing the models. First, I select the walls which goes, for example, in X or Y direction, not together. First the X direction or Y direction, and then the another direction, and then some walls with inclination. After the walls are all in the same plane, then I can move the corners. So I do it for each floor separately, these corners. And after the corners are okay, so all walls are correctly, then I can move the walls to the center of the slabs. And for this movement, you can use simply nodes and manipulate the nodes. You can rewrite the nodes, or you can create stories. So we can simply activate the coordinates of these nodes, right mouse button, view settings for selected elements, labels, display labels, Z coordinate. Okay, and I can now create 3 meter 2 times. So I have the floors. Now I can select everything. Oh, go out from this grid mode, select everything, go to the align members, and no, I don't want to align to master planes of 2D. I want to align only to story planes. Let's check if it is correct from the bottom, and you see everything is here. Okay, simply run the alignment and I have much better model. So this is the way how we can process the building. Now you see two walls. The one is bigger from the volume and this one is bigger from the surface. So let's check which one will win. Run alignment. We use 2D planes. Action preview. Aha, the bigger wall from the surface will win. So not the volume is important, the surface is important. You can use it because if you want to create some master planes, you can draw a very big walls through your structure. So and create your analysis statical and skeleton with these walls, and then all nodes will be moved to your planes which you have defined. Or you can do it with user coordinate systems, but the walls are very good visible. Could be maybe better. Okay, this can be saved. And I have another model, walls and distance of the walls. I will check my PowerPoint presentation to don't forget something. So align walls, corners, move walls. Okay, 1D elements. Align menu. Okay, this is everything explained. So we can continue align. I can do it for all elements because I have only these few walls. We are on from the top view. We have some walls here. See it, and we want to move. So the first function which I used was to select master planes and move to consolidate the master planes to one in this, well, everything which is within this distance. No, we don't have this issue. We have another issue. We have nodes. They are outside of this master plane and they have to be moved into the master plane. And there are two distances. The first distance is where is SCIA Engineer looking for these nodes, they should be moved. And the second distance is the maximal distance which will be about which the node will be moved. So for all these perpendiculars is the same number. But for this one, for example, I have a node which is in the distance of 500 mm from the master plane, but it has to be moved about 500, 900 mm. So we have to change the distances. We can simply write this to 0 because we don't have this to move the master planes. This is okay. And let's check. Let's write 0.2 and look at the preview. What will happen? Why it is not? Check it. 0.2, 0.2. Why this thing will be moved? I don't know why it will be moved, but it happened nothing. You see, it's only highlighted. Ah, it goes here. It goes here, and this is because it goes maybe. You see in this, I don't know what is done here. Doesn't matter. Maybe. This is the coordinate system. You see. Okay, my mistake. I go back to global coordinate system. Where is global coordinate system? Reset to global coordinate system. Okay. And do it again. Sorry. All entities. Change it to 0. Activate the live preview. Check the live preview. Okay. They are all selected and all will be affected, but this one is within 500 millimeter, 51 centimeters, but cannot be moved because the maximum is 51. Do we have conflicts? No. In the past, it was written also in the conflict, but doesn't matter. So change it to 0.2 and check the preview. So you see this one will be moved and this one not, because this is more than 20 centimeters. So we can try 0.31 and check it. Okay. 0.5, 51 for example. It's okay, but this one cannot be moved. We have to extend also this distance, for example, to 0.6, and then everything will be moved. So these are these two distances explained. The first one is the distance where SCIA Engineer is looking for nodes which should be moved, and the second one is the distance, the maximum distance which will be used for movement of the node. So if you want to keep these settings, you can simply say save and new, and then the run alignment, and then the settings are saved for your next call of this function. Why it's not done? Okay. All entities, so it has to use the same, and I have to click on again, align all members. Yes, action preview is there. You'll see as not, we need only display planes and run. Okay, I don't know what's wrong. So this was about these two distances. So we have three distances. The one is for the parallel planes. The second one is where is the engineer looking for nodes, they should be moved. And the third one is the maximum distance. So the nodes will be not moved orthogonally to the plate, but parallel with the 1D or 2D member which you have. So, and we can go back to our initial model. If you are doing this, then it's better. You will change the colors and you use very thin line, because these planes are not very thick and then you don't see the difference between the planes. You will also need the nodes. The nodes have to be activated, so you need the nodes. These are where their structural nodes have to be also activated. Okay, and as I explained on the begin, on the start, first I process the walls. So select the one wall. This is correctly wall. Right mouse button, expand selection, Ctrl E. I have only walls on my screen, so I can look on the top view, and you see some of the walls are parallel but not in the same plane, and also here and here. So, and therefore I would like to select these walls. Here you can do it better from left to right. This should be moved. Also these walls and this one. And I think this everything, all this and other walls not necessary. Ctrl E. So I have the walls which I have to consolidate. Select the walls, go to the alignment. You see I have very small distance, so I can go to 0.1 meter, change this to, for example, also to 0.1. 0.1, it jumps to the top, I don't know why. And I will not keep the original shape. I don't need the coordinate systems, I need only these planes of these 2D members, and activate the preview. So, and check what will happen. So this one wall will win and this inner wall will win. Okay, simply save and new and run. Okay, they are ready. Control Q, and again the same. You can save your selection, for example. No, this is wall. This was a window. Right mouse button, expand selection. Control E, go to the top view and select horizontal walls. These two walls have to be selected, and this one. Please select really completely the wall, because if you select only a part of the wall, you have more walls, and if you select only a part, then this one corner should be moved, and then another or not, and then SCIA Engineer has to move the wall outside of the plane. And this cannot be done, because then you get a 3D shell and then you get an error message. So better select from left to right, and I think this is everything correct here. Control E, select only these walls, select them, run the alignment. It's saved also with these distances 10 centimeters. Simply check the alignment, so they will be moved to the inner wall, and here the outer wall will win. Run alignment. So now we have walls, and you see this, there was some short wall. Okay, Control Q. We have walls really nice in one plane, and if you want, you can check it. Control E and go to the top view, and then everything is okay. The next step, after my walls are really in parallel planes, is to select one. I will not do it for the full model. Don't want to work here 1 hour. Control E. I have only one floor. And you see in this floor, these corners are not correctly connected. So you can select, you can try if you can select more or only one of them, and then imagine how long are these distances. We can run the alignment. So this distance of parallel planes can be simply changed to 1 centimeter. We don't need it anymore because our planes are correct. This distance is also used for openings. There is one magic button, keep openings in their original position. And this could be very important, because if you have, for example, a wall with some door, and these doors are very often, I don't know, 15 centimeters, and then you have some another wall in the bottom, and for example this one, then this node, if you select 20 centimeters, then this node will be moved to this corner. But here is not such nodes on, and then you get some lines with inclination, and therefore I deactivate this distance, because this is the distance in which SCIA Engineer is looking for the openings. So also if you deactivate this, or if you activate this button, keep openings in the original position, but if they are inside of this distance, they will be moved. So reduce this distance first. If you move the walls in one parallel plane, and then in next step you process the walls, then the openings will be not moved. So, and what we have to do, so I change it to, I don't know, 30 centimeters. Let's try. So you see, I have changed this value, and this is automatically changed because the distance of the movement cannot be shorter than the distance where SCIAEngineer is looking for the node. So this one has the same value as the first value or higher, but cannot have a smaller value. So try to save it, and it's okay. So you see, this will be correctly aligned or not. Again, it's because of this recording. Run alignment. Okay, again. So select this one. It's saved. Check it. Maybe it looks okay. Run. Okay. Let's check it for the next one. So in this way, and run again, and run alignment. It will be not done. Maybe there are some distances they have conflict. They are the openings. Let's check it. Okay. Run the alignment. Run. This is not done. On this way. Run. Here maybe the distance is too short. Write 0.51. Preview. Looks okay. This is done. Maybe this was too short, the distance. Sometimes we need a higher distance. Okay, run it, and rewrite from 0 to 0.51, and save and new, and run. This one will not be done. We can process it manually. Sometimes the nodes will be not moved. Sometimes you have to do it more times. Run align. Don't know why. Select them again and run alignment. Check the preview. Looks okay. Run. I don't know. Maybe in 3D. Select them again. Run. Check the preview. This will be not done. This is okay. This one is not okay. This one have to be done. Check the preview. Looks okay. Run. It's moved. Okay. Maybe I have to go to the preview. So, and on this way, you can process the full story. Run alignment. I will simply check it only. Go to 3D. Looks okay. Run alignment. Okay, they are perfect. You see, this is not very correct. So there are one opening, and in this opening there is another opening. Usually it should be not done on this way. So, and now we can select these nodes. Check the preview and run the alignment. Okay, the preview have to be checked. Okay, if you, I know why it was deactivated. I have to activate it. Sorry, it was my mistake. So, action preview, it has to be activated. If it's not activated, SCIAEngineer is doing nothing. And run alignment. Okay. So, and on this way, you get a nice model. Control Q. And after all walls are processed, you can continue with the connecting walls to the slabs. And here you have two possibilities. If you want, I have heard from customers, they use it also on this very simple way. Select the coordinate system from member. Simply go to this members. Now my coordinate system is in this member. I can simply select the nodes. I select them. So these are some short walls. On this way. Now I have all nodes. They are near my slab. and this is user coordinate system should be 0. So I move them to 0, or you can write 0, and then everything is done. The another way is you move them to the plate as before, but I think the better way is to use stories. So we need the correct heights. Usually the heights are not, you see the height is not on the plate, but it's on the top of the plate. So you need the stories on the center of our plates. So we have to go to the stories and write the correct value. I have calculated it before. Minus 0.01 is on the bottom. Then we have 0.58, 2.93, that was okay. Then we have 3.775. Then we have 3 meter 3 times, and then we have on the top 0.7 times 2.5. Okay, this is my model, and now I can select these walls. No, I have to go out from this line grid or stories, select them and say align, select it, but not in 2D planes, in the story planes. And we want to use the distance of 0.5. Okay, check the alignment, and you see everything goes in one plate. Run alignment, and everything is done, and it's then correct. Okay, and now you have to deal with the slabs on the end. So I hope it will help you a little bit. I will continue only with one thing. Go to the front view and select all these members. So Control E. So we have stories. So I will select all these members. Maybe only this one and maybe this one. So, and move them to the I have to move everything here. So move everything which is here to the floor. Run to the stories. I have to check it if the distance is correct. You see the distance could be a little bit higher. Let's say 0.8 and check it and try to run it. I don't know if it's correct. Okay, but for these nodes is okay. Now we have the member in the same plane as the slab, and I would like to change it to a rib. This is done in this function, modify, connect members and nodes, and here is connect 1D member as a rib. And then these 2D members, so 4 new intersections are created, 2 beams were selected to be connected, and 2 beams have been connected as ribs. So, and now we have real ribs. In this case, you have to be careful in one situation. And this is if you have wall and you have plate, and then you have somewhere your rib or some member. This is only one only member. If you select everything, then SCIA engineer have to decide should be this member a rib to the wall or to the plate. Decide for something. Sometimes it will be moved to the wall, and this is not correct. So therefore, during this connection of the 1D members to ribs, deactivate the walls, leave on your screen only the plates and the 1D members, and then connect nodes and edges only for these selected members. Then they are connected to the plates and not to the walls, because if they will be connected to the walls, they will also get rotation, and then you see it on the horizontal way. So it's not very nice, but the engineer have to do something, and if you leave the decision, then it's doing something. So you have to select that it should go to the plate. So I hope that this video will help you in your work and make your work a little bit easier. Thank you very much and bye.